Greetings, viewers. My name is Shuyu, and these are my teammates, Florence, Hiba, and Grace. Our project is titled Inequity in Education, the Correlation Between Neighborhood and School Performance in Ontario.
Overcoming systemic inequality is one of the major challenges facing our society today, with education lying at the heart of this issue. Inequity in education can perpetuate a vicious cycle where children of socioeconomically disadvantaged parents receive a lower quality of education than others, inhibiting their success in later life. The key to breaking this cycle is education.
So before we start, we would like to clarify the difference between equity and equality. Equity means giving more aid to the children who are struggling most in school, seen in the leftmost part of the figure, where the gap between advantaged and disadvantaged schools is closed. On the other hand, equality in education would mean everyone receives the same quality of education, shown by how both schools' performances increase by the same amount and the gap is maintained. Finally, having neither equity nor equality means students at disadvantaged schools, for example, those in socioeconomically disadvantaged neighborhoods, receive a lower quality of education, causing the gap in school performance to increase.
The United Nations recognizes the importance of equity in education with Sustainable Development Goal 4, which strives to ensure inclusive and equitable equality education. We use this goal as a benchmark of what we hope Ontario can achieve in its education system.
Firstly, we did a literature review on the existing research around education equity and equality in Canada. The OECD conducted PISA study is taken every 3 years and suggests that the Canadian education system is relatively equitable compared to other countries. However, national data is not necessarily representative of Ontario's education system.
Research at the city level by Gaskell et al. Examined EQAO scores and median income in Toronto, although they provided no quantitative results. Overall, there seems to be a need for a current evaluation of whether the Ontario school system has achieved equity, equality, or neither.
We seek to fill this gap in research by analyzing the correlation between a school's performance and its neighborhood, which can indicate the extent of inequity in our education system. In this project, we hope to quantify the current extent of inequity in the Ontario education system and determine which state the system is currently in, being one of either equity, equality, or neither. As well, we would like to isolate the most important neighborhood factors that can predict school performance.
First, we will talk a bit about the data we gathered, then go into the specific results we drew from each of our statistical analysis techniques. These techniques included principal component analysis to group the collected data, visual mapping and spatial autocorrelation using GeoPandas in the Moran's eye test, fitting several multiple linear regression models to our data in order to find their adjusted R-squared values and predict school performance, and hierarchical linear regression to isolate the most important factors.
We gathered data about each school's neighborhood, which we'll call its neighborhood factors, from a large variety of sources, some of which are listed here. A few non-neighborhood related variables were also included in our analysis to account for possible bias. These bias variables included factors such as the percentage of gifted or special education students in a grade.
To measure school performance, we used data from the EQAO, which is administered to all students in public schools in grades 3, 6, and 9, and we used results per school in reading, writing, and when available, applied and academic maths. We also used OSSLT scores, which is taken in grade 10. These results were then averaged over 3 school years, as listed. While results for the 2019-2020 school year were available, we chose not to include them, as the year had been interrupted by the pandemic, creating incomplete results.
We used a total of 127 variables in our analysis. Principal component analysis was used to group neighborhood variables by their eigenvalues, in order to determine which variables measured similar factors, which were then assigned one of 5 labels, as you can see on the screen here.
Before analyzing our variables, we wanted to figure out whether there even was a correlation between the neighborhood of a school and its academic performance. To do this, we mapped out school performance in Ontario using GeoPandas, Since schools are very densely packed in urban areas, we then zoomed in on Toronto. Higher and lower performing schools are clustered together, suggesting that there is some correlation between education quality and neighborhood.
The visual representation provides a great initial feel for the issue, but before diving further into our analysis, we want to statistically verify the visual correlation seen here. To do this, we calculated the spatial autocorrelation of school performance using the Moran's eye test. In this case, this test quantitatively measures the tendency for schools within a neighborhood to perform similarly on the EQAO. We found a Moran's eye value of around 0.3, as can be seen on the right, which rejects the null hypothesis and confirms that school performance is correlated to its neighborhood.
Right, so having established this correlation, our next steps were to further understand and quantify the extent of this inequity. So we did this by fitting several multiple regression models to all of the neighborhood factors we gathered. And by doing this, we found that neighborhood factors explain around 40% of the variance in performance between schools, with the exception of the grade 10 OSSLT. So the two maps you see here visually represent this result. On the left, the actual performance of schools is plotted, and on the right, you see their predicted performance as generated by our multiple regression models. And this predicted performance is based purely on their neighborhood. So when we zoom in on Toronto again, it's evident that our models are not very accurate, as suggested by the 40% correlation value we found. And the models especially fail at predicting very high or low performing schools. So overall, this first result leads us to conclude that inequity is undoubtedly still present in the Ontario public education system, but that the neighborhood and background that students are born into do not necessarily dictate their success.
Here, we compare the correlation between neighborhood factors and school performance as students move through the school by grouping the adjusted R-squared values we found by subject and comparing them from grade 3 to grade 9, as the grade 10 OSSLT is a separate test. We see that there is some fluctuation in the values over the grades, but overall, there is not a clear upwards or downwards trend.
R-squared defines a percentage of variance explained by a model, or essentially, in our case, the correlation between school performance and neighborhood. As Grace pointed out, we don't see either a strengthening or weakening correlation throughout the grades. So returning briefly to the idea of figure 1, this means that the worst case scenario, where there is neither equity nor equality, luckily does not appear to be happening in Ontario. However, we also do not see the gap in performance closing over time, as is indicative of equity. Therefore, we tentatively conclude that the Ontario education system has achieved equality in education, but not yet equity.
After we calculated the variance accounted for by all neighborhood factors, we then identified the three most important factors using hierarchical linear regression. The top half of the figure shows the top three factors that individually accounted for the most variance in each category. The bottom half of the figure shows the cumulative variance explained by the top factors. Most of the bars in the bottom half of the figure are one color, indicating that there is a large amount of overlap between the factors. As prior research from Pape et al. Also found, many of the top factors are related to income. Interestingly, the percentage of students with parents with some university education was a better predictor for school performance than more direct measurements of income, such as average household income.
Based on our analysis, a school's neighborhood only accounts for around 40% of its performance. While this is not ideal and there should be further efforts to try and decrease this value, it is intriguing because it suggests that the other half of unexplained variance is due to neighborhood unrelated factors, or internal school factors, you might say. So while we aren't able to easily change, say, the percentage of university educated parents within a neighborhood, we might be able to influence these internal school factors, such as the education level of teachers, for example. So future research into these internal factors might reveal simple steps that can be taken in order to improve school performance in all neighborhoods.
The role of schools in ensuring that all students, regardless of background, are given an education that provides them equal opportunity for post-secondary success is imperative in breaking the inequality cycle. We explore the correlation between the performance of Ontario elementary and secondary public schools on the EQAO and OSSLT, and a large range of demographic and geographic characteristics of their neighborhood.
We have found that neighborhood factors explained around 40% of variance in school performance. The most important factors determined by analysis included the percentage of students whose parents had some university education and the percentage of students who lived in low-income households.
Our results also tentatively indicate that our school system has, for the most part, achieved equality in education, meaning that students in disadvantaged neighborhoods do not necessarily receive a lower quality of education. However, equity in education, wherein the gap between disadvantaged and advantaged students is reduced, has not yet been achieved.
Thank you for watching, and we'll see you at the Big Data Day on February 28th.